Hi, this is Year 2 Pure, this is Chapter 9, Lesson 1, and today we're going to be differentiating trigonometry. Strictly we're going to be differentiating sine and cos. Tan comes later in the chapter, but you need to make sure that you've read Year 1, diff, and there's a little bit of other stuff to do with trig involved today, but you won't really need to read too far back onto that. Okay, so let's crack on. So the first thing that we're going to be having a look at is what are the rules for sine and cos? How do we differentiate those things? And the way that I used to remember them, we'll have a look at how this comes about in a bit. But the way that I used to remember them was this ladder, okay? And the ladder had sine at the top, and then cos, then negative sine, and then negative cos. And what that did for me was I used to remember that D is for down, D is for diff, D is for down, D is for diff, and we'd also have integration there. Now what that told me was that sine differentiated to cos, cos differentiates to negative sine differentiates to negative cos, and negative cos differentiates to sine. Okay, this ladder was just a quick way for me to remember the order of the things. I wanted to know which way they were going to go without having to kind of prove everything every single time. So we'll have a little look at a quick diff question. So for example, if you have y equals sine of x, then dy by dx will equal, well, sine differentiates to cos, you get cos of x. Okay, nice and easy. Y equals cos of x. Have a see if you can think what it might be. So therefore dy by dx will be next with sine of x. Dead simple. Where things get a little bit more tricky are when you've got either a coefficient here or you've got a coefficient to x. So I'll show you what happens if you've got, say, y equals sine of 4x. What you need to do is diff inside the bracket, diff that, and you'll end up with dy by dx is going to equal differential of 4x is 4, and then differentiate the sine. Okay, now sine differentiates to cos, and so then you have your 4x there. Okay, so diff inside, diff outside, diff inside the brackets, diff whatever's on the outside of the brackets, and that'll give you your result. So maybe you might want to try something that looks like, say, cos of 7x. So dy by dx will be diff this, gives you 7, cos differentiates to negative sine, so you'll have negative 7 sine of 7x. Okay, dead easy, really, really, really simple. If, for instance, you had something where you have, say, negative 10 cos of 4x, and dy by dx will equal, well, 4x differentiates to 4 times by 10 would be 40. We've got a negative, but cos differentiates to negative sine, so it will change that negative to a positive. So you get 40 sine of 4x. Okay, two negatives make a positive. One thing that might be a little bit more tricky, only just a little bit, is if you've got, say, for instance, sine of 2x plus y equals 0, and you need to differentiate that. Just make y the subject, and then diff from there. Okay, negative sine differentiates to negative cos, so you'll end up with dy by dx will equal negative 2 cos of 2x. If you've got multiple parts, if for instance you had sine of 4x plus cos of 7x, then you would have this stuff plus this stuff, which would be plus minus. Okay, if there's multiple parts, then you'll just combine together those multiple parts. All right, so here are some questions. You might want to just try them out. I'd suggest pausing the video, give them a crack, see if you can work those ones out, and then I'll go through them. Okay, so those are the answers for those questions. Pause the video, double check whether you got the same thing. If there's any differences, then have a little look at how you might be able to fix your work. All right, let's move on. So a curve has an equation y equals x minus sine of 2x. Find the stationary points on the curve. Now, the stationary points on a curve are where the gradient is equal to 0, okay? They could be a maximum, like that, gradient 0, a minimum, gradient 0, or there could be a point of inflection, gradient 0. But for all of those, dy by dx is going to equal 0 because you've got a stationary point. So if y equals this stuff, then dy by dx, well, differentiate the x is 1. differentiate the negative sine of 2x. And so you've got sine, cos, negative sine, negative cos. So that's going to be negative 2 cos of 2x. Okay, so when does this equal 0 is what we're trying to find out. So we have 1 minus 2 cos of 2x is equal to 0. 1 equals 2 cos of 2x. 1/2 equals cos of 2x. Cos to the negative 1 of 1/2 will equal 2x. Now what we're going to do is find a bunch of candidate solutions for this. Lots and lots and lots. We'll cast then, and then after that we'll divide by 2. You must remember to do that. You always leave this bit until last. Whenever you're doing cos to the negative 1, leave this bit until last. Don't divide and then cast. Now, because we've got 0 to 360 for x, okay, then for 2x we'll have 0 to 720. Okay, so let's work out our first value. So we've got cos to the negative 1. We have cos to the negative 1 of 0.5, which is 60. Okay, so 2x potentially could equal 60 degrees. Now we'll need to cast that. So there's 60. So this will be also 60 there, which will be 300. And then we get 360 plus 60, which is going to be 420. And then we get 720 take away 60, which is going to be 660. Now those are your candidate values for 2x. You always cast first, and then we're going to divide through by 2. So you get x is equal to 30, 150, 210, and 330 degrees, 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 and degrees. Okay? Now, the next thing that you need to know how to do is to be able to prove from first principles that the derivative of sine of x is cos of x. Okay, that's true, we know that, but to be able to prove it from first principles is quite advanced. All right, now this thing, you could be asked to do this, and to be able to do it you need to know how to deal with compound angles, and you need to know how to deal with small angle approximations. You also need to be really comfortable with differentiating from first principles. Now, the differentiation from first principles involves you saying that you've got some small, tiny value of h, which approaches 0, then f of x plus h minus f of x all over h will be your derivative. Okay, that'll be what you get for your derivative. So let's start off with sine of x. So we have sine of x plus h minus sine of x all over h. Okay, now sine of x plus h, we can use the compound angle formula to give us something different for that. So we'll have sine of x cos of h, okay, plus, means we get plus there, so plus cos of x sine of h minus sine of x all over h. Okay, now h is tiny. H is so small that it approaches 0, which means that it's small enough for us to be able to use these small angle approximations, where instead of theta we have h. Okay, so what we'll have is sine of x lots of cos of h, where h is so small that we can use this small angle approximation, which is 1 subtract h squared over 2, plus cos of x sine of h is so small that it approximates to h, minus sine of x all over h. Okay, now a bit of tidying, and we're going to end up with sine of x minus h squared over 2 sine of x plus h cos x minus sine x all divided by h. Alright, now what you can see is that sine x subtract sine x, they'll disappear. And what we'll have is going to be h cos of x minus h squared over 2 sine of x all over h. We'll divide through by h, we'll get cos of x is subtract h over 2 sine of x. As h approaches 0 though, negative h over 2 sine of x also approaches 0. Okay, now therefore the derivative of sine of x is just cos of x. And there we go. If you want a little bit of a challenge, you might want to try proving from first principles that the derivative of cos of x is negative sine of x. Okay, it's not sine of x, it's negative sine of x, remember the ladder. But have a little bit of a practice on some of those questions. Alright, thanks very much for watching. Visit numberclub.org to find some more videos and tasks. Thanks very much.